Hey everyone, so today we're going to discuss about the radius that is going to be formed at the interface when two bubbles or two soap bubbles are made in contact with one another. And let's start. First, let us consider two soap bubbles. One has small radius r1, okay, another has larger radius, that is r2. And let us consider that the outer atmospheric pressure is P naught and the pressure inside this smaller bubble is P1 and the pressure inside this larger soap bubble is P2. Now we know del P is equals to 4T by R for soap bubble because it has got two interfaces and this is the excess pressure which is inside the soap bubble. Now the excess pressure is inversely proportional to radius, so one that has smaller radius will have more excess pressure, right? So because this has smaller radius, this will have more excess pressure. That means P1 is going to be greater than P2, right? Because it has got less radius and excess pressure is inversely proportional to radius, so this one is going to have more excess pressure inside than the larger bubble. So for this, let's write the excess pressure, that is P1 inside greater than the outside, which is going to be 40 by R1, and for this one P2 minus P0 is going to be 4T by R2. Now when they coalesce with one another, if they're made in contact, what's going to happen? Something like this is going to be formed, okay? I'm trying to make this radius a little smaller than the radius in here. Why? Okay, so here the outside pressure is P naught, the inside pressure is P2, here the inside pressure is P1. Okay, so for this, what is the excess pressure? What is the pressure difference between the two sides of this membrane? P1 minus P naught. And for this one, what is the pressure difference between two sides of this membrane is P2 minus P naught. But here, what is the pressure difference between the two sides of its membrane? P1 minus P2. P1 is greater, as we have already told. So that's why it's trying to like sort of push in here because it has greater pressure. P1 minus P2. And we know that P2 is greater than P naught. Yes, P2 is greater than P naught. So because of that, its radius is going to be less than in here. Because you can think of it like this, because it has got less pressure and it was like easily able to expand a little, right? But here it was not able to expand as much because the outside pressure is greater than outside pressure in here. So its radius, the radius formed as the interface, is going to be less than its actual radius r1. Okay, so for this interface right here, let's try to find its radius. That's by equating this, right? What is the excess pressure in here is P1 minus P2. Okay, it's P1 minus P2, which is going to be, you can put this value like 40 by R1 plus P naught minus 40 by R2 minus P naught. So here we can do 40 by R, that is the radius formed at this interface. Radius of this little small thing formed at the interface is going to be 40 by R1 minus 40 by R2. So 1 by R is equal to 1 by R1 minus 1 by R2, and using this you can find the radius formed at the interface, which is right there in front of you. I hope you understood it. Thank you.